Hello everyone. This week we're going to talk about lesson 7, 6 and 7, page 55 to page 81 in your textbook. We're going to cover psi number and we talk about first complement, second complement, and then how to add the numbers together, either positive numbers and positive number or combine positive number with negative number. So let's look at the psi and magnitude. See, I have the table right here, and you can see the black numbers and the red number. In front of the number from 7 to 0, you see that the most significant bit, which is 0 here. So 0 here, I'm going to do red color. 0 here representing the positive, and then you have a negative for the 1. So if you have a psi number, the MSB, the most significant bit is 0, indicates the positive number, positive psi number. And if you have MSB equal 1, representing the negative psi number. Okay, so when you look at 10101, look at this number 5, for example. So the psi number is 0 and the magnitude is 5101. So if you look at the number 0101, so this one represents, the first one represent the positive sign, and then 105 is a magnitude, so that means 4 plus 1 equals 5. So this means positive 5, right? The answer here is a positive 5. Now, the ones complement, you just flip it, the psi number into opposite. So if you got 0101, you flip the first one is 0, second one 0, you flip to 1, and 1 you flip to 0, and 0 flip to 1. This the ones complement. Okay, so if you want to find out the negative decimal number representing about 1010, so you have to flip it back in order to find out that decimal number. Okay, for two complements, the first digits here representing the negative, because the sign number is 1. So in this case, you got negative here. This is 2. This means 1, 2, 4, 8, and 16. So multiply by negative 1 over here. So you got negative 16 plus 8 plus 2 plus 1. This one doesn't count. So then you got the answer is negative 16 and positive 11 equal negative 5. All right. So we're gonna find out more about how to add and subtract the number. Okay, first, the process how to find the two complements of a binary number. So look at this number. A bit was 001, 0001, 0101, 0101. So if I have this number and I want to do the two complements, what should I do first? I have to flip 0 to 1 and each 1 to 0. So flip it 0, 1, 0, 1, 0, 1, 1, 1. And second step is you add 1 to that number. So you got 1, 1, 0, 1, 0, 1, 1, 1. Okay, so that is the way you do complement given binary number. So make sure to change 0 to 1 and change to 1, each 1 to 0, and then add 1 at the end. So let's find the two complement representing the decimal negative 25 using 8-bit words. So I'm going to write down here number negative 25, do two complement representation of decimal number negative 25 using 8-bit words. 8-bit words. All right. So first thing I need to know is what's the number positive 15 first. And positive 15, that means 16 plus 8 equal 24. 24 plus 1 equal 25. So the answer is, I'm going to write down 1, 1, 0, 0, 1. That representing the positive 25. In order to find two's complement for this decimal number negative 25, first I have to make into 8-bit words. So I got 5 bits, you have to add 3 more 0 to make it 8. All right, and then you do the two complements by flipping 1 to 0 and 0 to 1 for each digit in this number. So I'm going to flip 1 to 0, 0 to 1. And then I add 1 at the end. So 1, 1, 1, 0, 0, 1, 1, 1. All right, so now we want to make sure this number is equal negative 25. So you want to check the decimal equivalent to negative 25. So I'm going to write down here, you got 1, 1, 1, 0, 0, 1, 1, 1. Okay, so because the first digit is 1, so the sign number is a negative. So this one is negative 1 times 128 equal negative 128. And the other one is a positive. So I'm going to add with 64. Oh, maybe I do a different color for positive number. I do 64. 32. 421. 421. All this number. All right, so then I add together all the positive number first. So you got 4 plus 2 equals 6, plus 4 equals 10, 10 and 3 equal 13, carry 1. 1 and 6, 7, 7 and 3 equal 10, 103. So negative 128 plus 103, and the answer equal negative 25. So this is correct number. All right, so make sure that you have to do complements by flipping each digits to the opposite one and add 1 at the end. And when you want to verify the answer, you check by using the decimal number. Then you make sure that if you have a one is in front is negative, then you have to multiply that one to the negative, and then combine the first one and all the numbers together, and then you find the answer. Okay. What would happen now if they want you to do 8 bits negative 12? You do the same thing, right? Now, how do you do negative 12? Let's do another example similar to this one, but do negative 12. All right. So that works slowly. What's 12 first? You want to do 8 bits words using 8-bit word to find number negative 12. All right. So negative 12, let's find out. So that means 8 plus 4. So you got 1 here using different number. So it stand out 1 and 1. 8 plus 4 equal 12. So it equals 0 here. And now you're going to do 8 bits. So you add 4 more 0 at the end. All right. And then convert that to the two complements by flip it 1 to 0 and 0 to 1. So I'm going to use using different color here. You got 1, 1, 0, 0, 1, 1, 1, 1. And then you add with 1 at the end. So I'm going to using a little bit bright in color. 1 and 1 equal 10, carry 1. 1 and 1 equal 10, carry 1. 1, 0, 1, 1, 1, 1. All right, we're going to check to make sure it's 12 or not. First of all, you know this is the MSB equal 1. That means negative number. So negative number, you got negative 128. So I'm going to write down negative 128. And this is all positive here. So I'm going to write down the positive number is 64 plus 32 plus 16 plus 4. So you got this is 20, 52, 52 and 64 equal 6 and 116. So subtract 116 equal 2 and equal 1. And this is negative, so the negative 12. All right, so that is how you find the two complements representation of decimal negative 12 using 8-bit words. All right, so sometimes they want you to add the number together, and in order to do that, the best thing to do is using the two's complement, because the one complement and the sign magnitude is not working well. So that's why we have to rely on two complements. So let's look at a couple examples here. A couple examples. One is let's say 4 plus 3. We're gonna do. I'm gonna erase this one. Four plus 3. Two positive number. Let's say 4 plus 3. All right. 4 is right here. Using the red. Okay, 4 plus 3. All right, so 4 is 1, 0, 0. Okay. And they're using 4-bit words, so you add 1 more 0 in here. and then add with 3, that means 1, 1, 0, 0. So add with 0, 0, 1, 1, and you add together equal 1, 1, 1, 0. So 0 is a positive number, so that's good. And then here you got 4, 2, 1, make it 7. So that's correct. So this is 7. 7 is correct. And down here you got 7. All right. What would happen if you add with bigger number using 4-bit words? See it working or not, like 7 plus 5. So let's erase this one. Erase this one. And using 4-bit words and add 7 and 5. 7 plus 5. 7 plus 5. Okay, so I'm going to erase here, make 7. 7, that means 1. Oops. Using red color. 1, 1, 1. But using, you want you to use 4-bit words. See if it's working or not. So I'm going to put down 4-bit words here. 4-bit words to add these two numbers together. So you have to add one more 0 over here. And the other one 5, that means 4 and 1. So if I'm going to use 4 and 1, make it 5, using 4-bit words, so I add 0 in there. All right, so let's line them up together. Line them up together. So 0, 1, 1, 1, 0, 1, 0, 1. And combine this together, you got 1 plus 1 equals 0, carry 1. 1 plus 1 equals 0, carry 1. 1 plus 1 plus 1 equals 1, carry 1. Okay, so the answer is 1, 1, 0, 0. Now you know this is negative number, right? Because it's the most significant bit is 1. So this one should be negative 8. It's negative 8. And plus with positive 4 equal negative 4. All right. Now, so 7 plus 5 equal negative 4. How could it be negative 4? So it doesn't work. 7 plus 5 should be 12. So negative 4 is not working. So what happened here? So that means you got 4-bit words is not large enough. So we're going to find something larger. So let's say you want to do 5-bit words. All right, so you add one more 0 over here. Let's add one more 0, 5-bit words. So you have to add one more 0 over here, one more 0 over here. So now, now you can add together, see what happened. Zero, 0, 1, 1, 1, and then 0, 0, 1, 0, 1. Now you add together, 1 and 1 equals 0, carry 1. 1 equals 0, carry 1. All right, okay, so now it's working because the last digits is 0, that means positive number. So you got A and 4 here equal 12. So when you have to use higher bit words. Let's do another example. Addition of positive and negative number together. Let's say if you got 25 plus negative 7. the 25 is the positive number using 8-bit words to rewrite as the binary number. So 25 is a positive, so it has 0 is side bit. Let's write out 25. That means 16 plus 8 equal 24 plus 1 equal 25. So you write down 25 equal 1, 1, 0, 0, 1, but using 8-bit words, so we have to add 0, 3 more 0, 1, 2, 3, make it 8. All right, so this one taken care of. Now 7, in order to do -7, you have to do 2 complements, and then you can combine together. So 7 is 4 plus 2 plus 1. 4 plus 2 plus 1 equals 7. Okay, and use 8-bit, so you have to add, you got 5, you add 3 more 0. Same thing, all right, with this one. Make sure the 8-bit words, so you have to convert to 8-bit words. If you don't have anything, add 0. Now you want to do 2 complements for positive 7, change to -7, do 2 complements. So I'm going to write down 0, 0, 5, 0, and 3, 1, 1, 1, 1. All right, that's a 7. You change to -7 by do 2's complement and add 1. So I do complement, flipping 1 to 0, 0 to 1. So I'm going to write out here 1, 1, 1, 1, 1. And then 0 and 0, and add with 1 at the end. So instead, I'm going to add 1 over here, add 1 at the end. Okay? All right, so now I can combine together, this together, combine them together. So I've lined them up in column correctly. So you got 5 number 1s here, 1, 1, 1, 1, 1. And then 0, 0, 1, 0, 0, 1. So then you combine them together, 1 plus 1 equals 0, carry 1. 1 plus 1 equals 0, carry 1, carry 1, carry 1, and 0. Now we got 1, 2, 3, 4, 5, 6, 7, 8. And 8-bit, and then 1-bit, it overflows, so you discard that one. Discard that one. So the answer is 1, 0, 0, 1, 0. And convert that to decimal number. So you have 0, 0, 0, 1, 0, 0, 1, 0. You know that this one is a positive because end up 0, so this is positive. And this is 2, 1, this is 2, 4, 8, 16. So 16 plus 2 equal 18. 18. So 25 minus plus with -7, that means -7 equal 18. So this one is correct. So make sure that you combine a positive and negative number. Instead of say adding or subtracting, I say combine one positive, one negative. Make sure the negative have to be converted to complements using two complements and add one. And then you combine with the first one, you got the answer. Let's do another example when the number is two negative number. We do the same thing, let's say negative 15 and negative 16. So I'm going to erase this one. And I'm moving over here. I say, hey, combine this negative 16 and with negative 15. Okay, so let divide letters so easy to see. So negative 16, that means first of all you have to find two complement for 16 first. And 16 is equal, I'm going to write out here, 1, 0, 0, 0. And they want to use 8-bit words. Make sure that write out 8-bit words over here. So you have to add 3 more 0 in here. 1, 2, 3. All right, and then you write out and then you convert it and add 1. So I'm gonna do two complements for the negative 16. So I'm gonna write down here 0 converted to 1 and 1 converted to 0. Flip the number 1, 1, 1, 1, and 0, and 3 number 1, 1, 1, 1. So you got 8 bits worth for number 16. And then you add 1. And combine together, you got 0, carry 1, 0, carry 1, 0, carry 1, 0, carry 1, and 1, 1, 1. All right, so that is number negative 16. And then for 15, you write out a plus 4 equals 12. So you got here, number 15 is 12. 12 plus 2 equals 14. 14 plus 1 equals 15. And then put 0, 4-bit, 8-bit words in here. And then you convert. You do two complements, two complement, and then you can add 1 at the end. So complement for number 1 is 0. Oops, using different. Okay, that's fine. 0, 0, 0, 4 of them. And then for number 1, and then add with 1. So then I got 1 and everything else. All right, now I can combine these together. I line them together on top of each other. So I'm going to write down, I bring the yellow to the right. I write out for number 1 and for number 0. And then I add together, you got 1, 0, 0, 0. 1 and 1 equals 0, 1, 1, 1. Okay, so you know that is a negative number. So you got 1, 2, 3, 4, 5, 6, 7, 8. So this one is you throw it away, discard them. So you got 1, 1, 1, 0, 0, 0, 0, 1. Okay, so you got the first one is negative. Write down negative 120. Up right down here, negative 128 for this one, and then you got 64 and 32. write out the positive number, 64 and 32, 64 and 32, and then you got 1. All right, so I add the number, positive number together first, 97. So you take 128, subtract 97, equal 31, and negative. All right, so negative 16 plus negative 15 equal negative 31. So this is your answer for that problem. Okay, so basically when you have a subtraction problem, you convert to the addition problem. So let's give another example. So let's say if you got negative 42, right down here, negative 42, and then you subtract to 7. In algebra mean negative 42, you add with negative 7, like that. All right. So first, you find 2 complement for negative 42. So 42 equal 32. Let me say it right. I'm going to put red color. 42, negative 42, that means 32. 16 is too big because 48, so you cannot do that. 32 plus 8 equal 40. And cannot be 44, 42 right here. And this one 0. So that 42 using 8-bit words, the same thing. So I'm going to add another 0 and 0 in here. So that's why you got negative 42. Okay. All right, negative 7. Negative 7, I got 4 plus 2 plus 1. So 1, 1, 1. And then I add 0 in front of that, make it 8-bit words. Okay, so I got 2 numbers, and then I convert to 2 complements, add 1, and then I combine together. So let's do complement for the first one. So I'm going to write out, I'm going to divide this. I'll do 42 to the left, negative 42 to the left, and negative 7 to your right. All right, so I convert the first one here. So I flip it 0 to 1 and 1 to 0. All right. So you got 1, 1, 0, 1, 0, 1, 0, 1, and then you add 1. And then let's do one step at a time. Let's do it to your left first. And so you add 1, you got 10, carry 1, 1, 0, 1, 0, 1, 1. Okay, for negative 7, you do 2 complements and then you add 1. So I'm going to do 5, 0, flip it to 1, 1, 1, 1, 1. And then 3 ones I flip to 0, 0, 0, 0. And then I add with 1. Okay, so 5 ones in here. All right, and then I combine these 2 together. All right, I lie on top of each other. So you got 1, 10, 10, 1, 1, 0, 1, 10, 1, 0, 1, 1, 10. Make sure that I read it correctly. And then I add together, you got 1, 1, 1. 1, 1 and 1 equal 10, carry 1, carry 1, All right, and then you got 9 bits here. So discard this one. So you're only using this one. And one is a negative again. You got 1 1 0 0 1 1 1. It means negative 128 plus 64 and plus 15. So 64 and 15 equal 79. So 128 and 79, you add together, you got 9. And 11 subtract 4, 7 equal 4. So negative 49. So 42 plus 7 equal negative 49, and the answer is correct. So I will write down all the numbers that you have in your textbook from page 55 to 81, and then you're gonna do straight from your textbook, make a copy, scan it in either PDF or JPEG, and then upload to Canvas for the assignment for next week. Okay, I hope you have a good week, and if you have a question, as always, call me in team or email me. All right, have a good week. Bye-bye, everybody.